I just described. And then there's creating deliverables and getting information and meaning out of your scan data. And that's all done in the Office software. The Office software that we use is Trimble RealWorks Advanced Tank. Now, this is a software that's used specifically for laser scanning, and this edition is made specific for those in the storage tank industry. It handles all of the registration, putting each of those scans together for you, whether you're using targets or no targets, so you have flexibility to work however you like. It also has the ability to go and classify the different components of your tank, which I'll show you a little bit later. Huge time-saving benefit there. It allows for tank inspection, calibration, evaluation of the secondary containment. Also has modeling tools and other analysis tools to go in and analyze your tank. Now, the software, when we're talking about doing storage tank inspection, most of the automated tools are applying to vertical cylindrical storage tanks, like you see here in the top, or horizontal storage tanks, like you would find in a rail tank. When I talk about the classification earlier, the first step is to go through and let the software identify automatically the different components of the tank. So, for example, identifying the roof, the shell, the floor, the deadwood being anything inside the tank that would subtract from the volume, and then identifying everything else that it doesn't know. It could be equipment or people walking around in the tank that needs to be removed before you can do your analysis. Now, this is something that could take days in the past before software was developed specifically for storage tanks, tediously going and removing sandblasters and air compressors and trucks and weeds and grass and spiraling staircases. And all of these things could be very tedious. The software has got this down to be a very quick process. Now, when we talk about next is tank inspection and tank calibration. I have no idea why I get these news updates here. Tank inspection is the process of going through and visually and electronically determining the physical state of the tank and its environment. So you can imagine if you were to buy a new house or a new car, you would go through and inspect it. You would make sure there were no dents, that there was no rust. You'd look at it visually. You might take it to a mechanic to get inspected. Same thing with storage tanks. You want to go through and make sure that these things are sound and ready for use and for a long time. Tank calibration, on the other hand, is the process of determining the correct volume of a substance that the tank can actually have, going from different measurement marks. These are two things that we address within the Trimble RealWorks software. Start out by looking at the inspections. Now, a lot of the benefits of using laser scanning for storage tank inspections is that it's reducing the field time. Typically, one person can go out and scan a whole tank within an hour. Now, certainly if it's a gigantic tank and you need a lot of extra detail, it could take more. But if you're able to get inside a tank, scan inside, see the bottom, the shell, the roof, you can do this very quickly and easily with a laser scanner with a single person. As we saw earlier, you get detailed, accurate data on the entire tank. So the laser scanners can see this down to very, very close spacing on these points, so nothing is missed. Also, like I showed you earlier, it provides this great visualization with different tools being able to highlight different areas or problem areas with the tank. And it gives you that complete verticality, complete roundness, and as well as complete shell settlement and any distortion analysis, and allows you to take any of these measurements from the safety and comfort of your office desk. Now, when we look at the storage tank inspection, we'll go in and look at setting up the tank. So you can see it's using terminology and workflows familiar to those in laser scanning, such as defining, or storage tanks, such as defining your courses, adding, removing the position of welds, it's all in very easy step-by-step. You see step 1, step 2, step 3 to go in and measure these tanks. Then you will go through and create ultimately a verticality report. Now you can see here, this is kind of an amalgamation of talking to many involved in the industry, creating a report, trying to fit in most people's needs. Everyone has slightly different ways of doing their reports over the years, and we've tried to incorporate as many as we could. On the left side here, you'll see the graphical representation of the tank. You can imagine the tank overlaid here and cut in half. These are those even intervals, so you imagine like slicing a pizza. So you see station 1 on the left side. The middle, where you see that orange line, is the theoretical perfect tank shell that would be vertical. The green lines are the tolerances that we've set within the software. And then the blue line that's kind of zigzag and has the nodes, that's an exaggeration of what the tank shell is actually doing. Now, again, we exaggerate it so it's easier to see what's going on and where areas are getting out of calibration or out of tolerance. Now, on the right side, you see the station opposite it, in this case, station 5. And you can see that most of that is all within tolerance. One area on course 4 is just about to get out, but it is within tolerance. Whereas on the left, you see on station 1, several areas getting out of tolerance. Now, on the right side of the screen, you see the same information displayed in a table form. So this is all data you can copy and paste into a spreadsheet. I know most people doing tank inspection or calibration have created spreadsheets over the years that they use. This data, you can just copy and drop it right in if you want to use something you're more familiar with. And then at the bottom is a comparison to perfect cylinder, so you could see what was going on at any place on the tank, whether it's tilting in or it's bulging out. In addition, we also generate roundness reports. Again, this should look fairly familiar to most of you. You can imagine the tank center here, the perfect round tank in the middle, with the green lines being the tolerance values that we've set. These are all customizable, so you can enter whatever tolerance values you want to meet whatever standard you're trying to meet. And then, of course, the blue line going around is the exaggerated view of what the tank shell is doing. So you can see up at the top of the screen, the blue line's getting just outside of the green tolerance values. And then if you look at the table down below, you can see, in fact, that at that position, we are failing. Now, another thing that's of particular interest to inspection and construction is the settlement, the edge, and being able to look at this and know what's going on over time, because you've got all of this weight pushing down on the outside of the bottom of the tank. These shells are quite heavy, and they'll certainly start to bend down slowly over time, or have the potential to. But what you don't want to have is, if you look at the graph on the right, an area where it's bending too sharp, too close, and this will typically happen close to the edge of the shell, where the bottom meets the shell, and that could cause problems. So we've got tools that allow you to go in and analyze this. Now, traditionally, you would probably start with a laser level or something, and you would have somebody with a level rod with elevations on it, and they would start out at the tank edge, and they would start working their way towards the center of the tank. Now, taking the measurements very close together at the outer part of the tank, because that's where you're going to run into these problems, and then moving towards the middle of the tank with a bigger spacing once you get to the middle, because you're not as worried about having this problem of the shell pushing down in the middle. So because of that, on the outside, you have many close measurements. If you see the green dots in the lower left-hand corner, and then as you get closer to the middle of the screen, or the middle of the tank, you can space these measurements out a lot farther. That's how you would traditionally do it. Of course, with laser scanning, you'll see all of the bottom. But we also have tools that allow you to analyze the entire bottom. So you can see here in this screen snap, we've got the evenly spaced inspection stations going around the tank, but we've also done that analysis where we look at a perfectly flat floor, and then we compare it to the point cloud to see, now it could be flat, it could be cone up or cone down. Let me make that clarification. If there's any extra deviations that aren't on there. So in this case, we found some areas that are maybe falling in between those regular inspection stations. So we're adding an extra row of inspection there so that it will show up in our report. Now, when we create our reports, you can see on the left side, just going to move my mouse, you can see we've got many stations starting here along the shell. And as we move towards the middle of the station, the middle of the tank, as I mentioned earlier, the spacing on these measurements is a lot farther. Now, the reason we have these like this is we know most people are familiar with looking at traditional tank inspection reports. So we're handling all the traditional ways of viewing it and the way the standards are built. And in addition, we give you these extra tools to go in and analyze and look at the entire tank surface, the bottom or the shells, so that you can make more decisions. So just to make that clear, we're trying to follow the standards, API in particular, as close as possible, knowing that you'll also use additional tools to get the maximum value out of your laser scanner. Now, when we look at the tank calibration, we've got a separate set of tools for tank calibration. Within these tools, you can see the UI here. You'll go in, define the position of the dipping plate by picking a point, or you could do a best fit flat plane to these dipping points, these dipping plates. You can also go in, define the maximum level. You can type in a value, or you can physically click on the point cloud of the tank to define this. And then you can set an interval. You could think of these as virtual strapping, how often you're going to check the circumference of the tank starting at the bottom and moving up, starting at the dipping plate and moving up to that maximum level. Then we'll also calculate below the dipping plate. That will all be considered the sump area. We'll create a volume on that as well. Now, we do have the ability to enter a shell thickness. However, we're not so sophisticated that you can put in different shell thicknesses. I understand that you'll have different thicknesses as you go up the tank. In this case, you would probably have to figure out an average if you wanted to do this. This would only be considered if you scanned the tank from the outside. We would assume most people doing a volume calibration would be scanning from the inside, in which case you really don't need to worry about the shell thickness. It would only be if somebody wanted to scan a tank from the outside to calculate the volume. Now, once you've done and you've got all of your virtual strapping done, this simulates wrapping a tape around the tank. You get the true circumference at each of these intervals going up the tank, and you saw that those were custom defined. Then you can go through and inspect each one of these to make sure that they've extracted properly. Again, the software tries to do as much as it can automatically, but it tries to err on the side of caution, so we don't want to do something wrong. So everything has the ability to go through and manually inspect what's been done automatically and make any changes if you need to. So in this case, you can see on the right all of the different sections that have been created. We can just click on the arrow to go through each one and just visually check to make sure that that line is actually following the tank shell and didn't miss a hole because of a manway or something that needs to be filled in, or to maybe we didn't do a good job cleaning and we missed a nozzle or something, and it virtually measured over the top of that nozzle. So you can go through and check each of these. Once you do that, you'll export out a strapping table, which can then be brought into another application we have to create your tank calibration report. So once you import that strapping table, here's the parameters for importing that. It will populate each of the fields, and then you can go through and set all of your compensation values and then create parameters for how you want your calibration table to be created. and it can interpolate between each of those intervals. So the nice thing with laser scanning is you can actually create those strapping intervals as close as you want. It's no more effort than to do 100 than it is to do 2, really. You just type in how many intervals you want it to do. But once we create the capacity table, we then can even further define the filling table intervals that we want on here. So in this case, it looks like we've done one every inch. Now you could set that to be pretty small. I think I don't remember the smallest value, but it's pretty small. Probably less than a 1/4 inch. So ridiculously small. Now, I will tell you that when we calculate our filling tables, this is based on an empty tank, not accounting for any dead wood. It's removing all of the dead wood, so that's not being subtracted from these. If you want to do that, you would do a mix of what we currently have with the automated strapping table. Then you could manually take all of the measurements, again, in your air-conditioned office where it's nice and clean and safe. You could fit pipe, you could measure any kind of support structures and get those measurements and then manually enter those into any other spreadsheet that you've been using over time. So even though we don't have the automation to account for dead wood or floating roof displacement, because these are pretty difficult things for the software to automatically figure out, especially for scanning, because so much of the dead wood could be heating or mixing components towards the bottom of the tank, which is difficult to get the scanner under them. The human eye can look at them and measure them and know them, but automated is pretty tricky. The next thing that we look at is secondary containment. So if you're going to go and measure the dike walls, the earth walls built around a tank, or concrete walls, we've got automated tools to help you there as well. In this case, we've got tools to automatically clean the ground to remove vegetation, people, vehicles, equipment that might be parked out there temporarily to get down to the bare ground. Then you'll define the area of this boundary that you want to calculate the volume for. You then can create the criteria that you want for a report, and you can enter in rainfall parameters as well. Most of these tanks, when the secondary volume is containment areas are created, they need to account for a heavy rainfall that could happen at the same time that a tank would fail. And then you'll get a report showing the volume area, how much it will hold, and displayed as a percentage of the tank. In this case, it would hold 58% of the tank. The software is automatically looking at the tank and extracting that. Now it's not an exact measurement. It's basically looking at the bottom of the tank and the top of the tank, creating a cylinder and creating that volume, and then adjusting the volume of the containment area to that. Now, I will mention this tool is only working on one tank in a containment area. If you had a containment area built to contain, say, 4 or 8 tanks, you need to run this multiple times. Now, in addition to the automated tools, we have several semi-automated tools that will allow you to go in and do inspection. In this example, looking at the support structures inside a tank, maybe it's being retrofitted or upgraded to be a floating roof tank. You need to make sure that everything is fitting, or maybe during tank construction, you want to go in and make sure everything is aligning perfectly. So on the right, you see that I've created cross sections of the tank and then displayed them in unique ways. So on the left, you'll see one vertical support, and you can see that we've taken a check on it every 1.5 meters. Then if you look in the middle part here, you'll see each of those rings is what the tank is really doing. And in the middle is just a reference of where the true center of that support structure is at the bottom. So you can see that it moves in different directions. It starts out being, dead center at the bottom on the support structure. Then it starts to meander and go down towards the bottom, and then over to the left, and then starts to twist around to the right. these are kind of hard to describe to engineers, right? They just say which way it's leaning. You need to tell them, well, at 1.5 meters, it's starting to go north. And then at 3 meters, it's starting to go north and east. And then maybe at 9 meters, it's going south, southeast or something like that. On the right, you can also see another visualization. So that's the beauty of 3D and having all of the data. Makes it really clear to be able to go in and look at these tank structures and see exactly what's going on and where, so you can make informed decisions on how to go back and make repairs or adjustments on your tanks. One more thing I'd like to mention, in the Trimble RealWorks Advanced Tank Edition, you also have all of the modeling tools available. So I used part of those in that last analysis for the structures. If you're doing other facility type work, we've got tools such as these automatic pipe extractions or manual pipe or cylinder modeling, so that you can model your entire facility. So if you're looking at upgrading or renovating, or maybe you just have no idea about any of your assets, laser scanning is a really quick way to capture the entire facility, including all of your tanks, and do analysis on all of this. And it's all in one package. Now, one interesting thing, I've been talking about laser scanners, but a lot of the inspection companies I've been talking to have started to employ drones in their inspection and creating point clouds from their drones and then doing quick calculations on things. You can bring the point cloud data from pretty much any source into Trimble RealWorks. It can be handheld laser scanners, the full-blown laser scanners like I've showed you here, point clouds from photogrammetry or drones. So it's very flexible in the way it can work with your data. And then finally, you'll want to probably share this data. You'll give your clients the reports for sure, but many of the clients have seen the beauty of laser scanning and the benefits of having these whole tanks as a digital copy on their computer and being able to share those with their engineering teams. So they've been asking for the point cloud or representations of the point clouds that they can use in addition to their reports. On the left here, this is an example of creating a published project using what we call Trimble Scan Explorer Viewer. It allows you to create a self-contained kind of viewer report, if you will, where you can add in media such as documents that could be all of your reports. You can add in images, you can add hyperlinks to web pages or email addresses or to other documents. You could even bundle in CAD projects and have links to those, so if they had the right software, they could open those. And then you also have the option to go in and put your own company logo and the ability to extract the point cloud. So they can look at this nice view like you see here on the right with annotations or add annotations. But if they wanted to, they could extract the full 3D point cloud out of there. It's up to you if you want to give your client that ability to extract that out. And you can also change the size of the file. So if they just need some of the points, you can keep the file smaller. That's what you see on the left where it says data file size. And it makes a really convenient way to share the data and what's going on. You can also, on the right, as you look through there, we call it a station-based view. It's very similar to like a Google Street View, where it's kind of the first-person view as if you were standing there, and you can rotate around and look, take measurements, add annotations, etc. So how to get started? So if you're looking to get started with this, start out by going to our Trimble website for storage tanks. You can do a screen snap of the link there, or you can just go to trimble.com and find it under our solutions. I just type in to Google Trimble storage tanks and it pops up at the top of the list, and I click that link to go there. Once you get to the website, it's got all of the information you could want on storage tank solutions. It's got all the information on all of the laser scanners that I've showed you today. It's also got links to all of the information about the software, as well as specifications, system components. Also at the bottom, you'll see news stories or testimonials or different places that stories about our solutions have shown up that you can click on to read about or to watch videos on. And if you look at the top, there's a button called Where to Buy. I know that's a bit presumptuous, but that will take you to our dealer locator. If you click on that, you can type in an area where you want to find your local Trimble dealer. Now, certainly we like to sell things, and that's how we keep in business. But more than that, we like happy customers. I would never want somebody to buy something that they're not happy with. So I would make sure you reach out to your local dealer and set up a demo. Say, hey, I'd like you to come help me scan a tank, or you could rent a scanner for a week to try it out if you wanted to, but make sure you try the solution out and make sure that it fits your needs for what you want to try to do. In addition, you can, oh, sorry, there's a contact button. I see you're getting little updates here on the bottom from my marketing person that keeps me on check. You can probably read the notifications as they're popping up. So there's a contact button on our web page, and then that's where you'll go to find. Then you'll want to request a 30-day trial license for Trimble RealWorks. So you can go through and try it. Your dealer will be able to give you training, get you started on that. If you don't want to wait, you can also go to the official TRW, that's Trimble RealWorks YouTube channel, where you can watch training videos on how to get started with the software, doing the import, the registration, step by step, how to do analysis on the point clouds, and as well as videos on the storage tank solution. So in summary, we have a very efficient solution for tank inspection and calibration. It greatly reduces your field time. As I had mentioned earlier, a single person can scan a tank most times in less than an hour. If they get really big or you want more detail, it may go to a couple of hours. The software, the automation in it is really key. In the past, I would talk to customers and they would be spending up to 5 days going through and trying to work with scan data to create results. These were before a storage tank specific solution existed. They've been able to drastically reduce that amount of time. And as well, there's also opportunities then to expand your business. So if you already have a scanner, you're already scanning your tanks, you can see that there's areas to move out and start to scan more facilities. If you're just getting into this, you can see the benefit of using the laser scanner for a number of different areas. So with that, looks like I'm right on time. I will open it up to